Hello class, this is Mr. Eggleston, and this is this Check Your Understanding for lesson 6.7. 6.7, I didn't even do that last lecture on this video, but it's 6.7. The first question is just to basically estimate without a calculator what square root of 65 is. Well, square root of 65 is not a perfect square, so it's going to be some decimal that's probably going to be pretty ugly looking, but can we get an estimate about how big you should expect it? Well, yeah, if you just do some thinking, we know that the square root of 64, well, 64 is a perfect square. The square root of 64 is 8. And we know that the square root of 81 is 9. So 65, square root of 65, has to be between the square root of 64 and square root of 81. Logically, I hope you get that. And notice, 65 is really close to 64. So you'd expect that the square root of 65 will be really close to the square root of 64. So I'm going to say the square root of 65 is about 8.1. Now let's use a calculadora to calculate that, what the square root of 65 is. So we're going to go, got it clear. We're going to go square root of 65 equals, and we see it's 8.06. So square root of 65 is 8.06 calculator, right? So you see that if you use some logic, you can actually estimate and get a decent estimate of what the square root of a number is, all right? In calculus, you'll learn how we can get a much more precise approximation using some simple calculus techniques. That's not so simple to you, but to calculus students, it would be very simple. Now, without a calculator, determine which is greater. The square root of 40, which is some number a times a, right, will give you equal 40, or the cube root of 40, which would be a times a would equal 40. Okay, so which one would be larger? Well, the square root of 40 would be larger because you only, if I can spell only need to multiply the number against itself once to get 40. Once. Whereas cube root of 40, you would need to multiply the number against itself 3 times. So it would be some number a times a times a. So you need more of them to multiply. So to get to 40, so square root of 40 would be bigger. And we can actually see what the difference is. So the square root, the square root of 40 is 2.515, I guess. And the cube root of 40 is 3.41. All right? Again, the cube root's 3.4, and the square root of 40 is 6.32. All right? So you can see it would take, the square root is bigger than the cube root. Okay, the volume of a cube is 150 cubic units. Find the side length of the cube. So what that means is the volume of a cube would be side times side times side, right? Width times length times height, or side cubed. Hence the name, anything to the third power is cubed, because it's the volume of a cube of side length s. So if s to the cube to the third power equals 140, s would equal the cube root, because it undoes the cubing of 140. Using calculadora, it comes out to be about 5.31. Okay? Now, let f of x equals the square root of x plus 1 minus 4. It wants you to graph the function. Well, remember, the graph of a square root looks like this. It has a starting point, and we got to figure out where that start point is. So looking at this, we see that the start point is at -1 comma -4. Remember, your x's are liars. So when it's x plus 1, it shifts the graph to -1 on the x-axis, and the -4 just means it goes down 4. So the starting point is right there. Then, it's so easy to graph, and once you find the starting point, you go over 1. What's the square root of 1? Is 1, and you go up 1, and we're here. If we go over 1, 2, if you know what the square root of 2 is, it's 1.414. It's an ugly decimal. You could estimate that, and it'll be somewhere here, but why do that when we can go over 1, 2, 3? Well, the square root of 3 is 1.7 something, which would be a little bit higher, right around there. But luckily for us, if we go over 1, 2, 3, 4, the square root of 4 is 2, and we go up 2, and you get a nice point there. There's another point. And then likewise, if we just go over 9, if it fits, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. You go up 1, 2, 3, and there's another point, and here's your graph. Okay. Find the domain of the function. Well, the domain, D, is always going to be x is greater than this or equal to the starting value of x, where it begins, because it only goes to the right. Later on, you'll learn how to reflect it and stuff in Algebra 2, but for us, it just goes to the right. The range is y is greater than or equal to -4. Excuse me, -4. I'm going through changes here. And again, remember, range is the output, so it's the y value. So you look along the y-axis, you see it begins here at -4, and then it goes above it. Hence this. Likewise, the domain is the x-axis, so we go along the x-axis, and we see it starts here at -1 and goes to the right. So that's how you graph this. Now, if 3x squared plus 5 equals 38, find the value of 3x squared, then find the value of x. Well, if you subtract 5, remember we want to isolate the 3x squared, so the x squared actually. You get 3x squared equals 33, excuse me. And then, if you really want to find the value of x, you divide by 3 and get x squared equals 11. And then x would equal the square root of, because it undoes the squaring, the square root of 11. Okay? And that is, if you use a calculator, is 3.32. Okay? There you go. Something that you should be aware of is that it's not just a positive value. You're going to find out, much to your chagrin, is that it can also be a negative. Because think about this. If you square a negative square root of 11, you will get 11 out again. Because negative square root of 11 times negative square root of 11, it's a positive square root of 11 squared, which is 11. So it's also negative 3.32. You get two possible solutions. Two solutions. You almost always will get two solutions, a positive value and a negative value, especially if we're solving equations. All right, and that is the end of this. So I hope that makes sense. Have a wonderful day. Bye-bye.